I'm sure you guys have seen the DeepSeek R1 models release all over the news, and you know how it's taken the tech industry by storm. In this video, I'm going to tell you exactly why it's such a significant discovery for the AI industry, and then I'm going to break down the technical concepts behind DeepSeek R1's success in simple terms for people that have absolutely no experience in tech. So if you're a tech enthusiast but have no clue about all these big words everyone's been using like reinforcement learning and distillation over the past week, stick until the end of this video, because I promise you, you will know more than 99.9% of people. So without further ado, let's get right into it. So in order to understand the relevance of DeepSeek R1, you have to first understand the concept of chain of thought reasoning. So chain of thought reasoning, in simple terms, is actually just telling the model to think out loud. So instead of you giving the model a prompt and the model just giving you an answer, you want to tell the model that when you give it a prompt, you want it to think and also vocalize its thoughts, or basically tell you what its thought process is, and then eventually reach an answer. So if we want to have a look at an example here, for example, if we tell the model, if you have 10 apples and you give away 4, how many apples are left? The model would first think, okay, we're starting with a total apples of 10. And if we subtract away 4 apples, then the calculation is that we have 6. So the final output is that we have 6 apples. Now, this is a very simple question with a simple sort of 3-step process, but imagine a really complex problem where the model would think through multiple steps. And as it's thinking through multiple steps, it's vocalizing it so you can also see what it's thinking about. And realistically, at its core, that's just what chain of thought reasoning is. And that's the whole concept behind reasoning models. And the reason why chain of thought reasoning is quite popular these days is because researchers realize that if they can just get the model to think for longer, then the outputs that the model will give are generally going to be more accurate. So they realize that instead of just trying to make a better model that's better at giving you outputs straight away, they can get models that think through problems for longer and eventually give you better outputs. And this was the whole idea behind reasoning models. So they wanted to build models that weren't just word predictors, that weren't just models that would predict the next word, giving the words prior to it. They wanted to build models that were actually able to replicate the thinking process of humans, or models capable of thinking. And building these models that are capable of thinking is actually super significant towards the development of AI, mostly in the implementation stage, because if you want to have models that are able to solve complex problems, you want to have models that are able to break down the problem and think through the problem in order to give you an answer. And this is just basically what these days we talk about in terms of AI agents. So reasoning models are actually the backbone behind fully autonomous AI systems that are able to solve complex problems, or in technical terms, AI agents. Now, if you want to look at this even one step further, these reasoning models are going to get us closer to AGI, or artificial general intelligence. So yes, reasoning models are a big deal in 2025. Cool, so now that you guys understand what reasoning models are and why they're significant, let's take a closer look at DeepSeek R1 and why it's been the top headline for the past week. So till now, OpenAI's O1 reasoning model has been the best reasoning model by quite a big difference in the industry, and honestly, no one's been able to replicate them. But about a week ago, DeepSeek released their new R1 model, which took the world by storm. So if we take a look at the relative performance of the two models, you can see that DeepSeek's R1 and OpenAI's O1 actually perform quite similarly on the main benchmarks when it comes to reasoning models. So as you can see, DeepSeek R1 actually beats OpenAI on 3 out of the 6 benchmarks shown in this image. So in terms of performance, the two models are quite comparable, almost the same. But the main reason why DeepSeek's R1 has taken the world by absolute storm is because of the difference in pricing when it comes to these two models. So if we take a look here between O1 and DeepSeek R1, as I said, the performance is quite comparable, but when it comes to pricing, DeepSeek R1 sits at $3 as a blended price for 1 million tokens, and O1 sits at about $26. That's almost 9 times more expensive than DeepSeek's R1 model. And in terms of the output price, it's actually almost 20 times more expensive than the DeepSeek R1 model. And what's insane is that DeepSeek R1 actually claims that they built their model for about, I think it was $5.8 million, whereas OpenAI's O1 was built for about $100 million. That's absolutely insane. So in this next section, I'm going to break down how DeepSeek built their R1 model in super simple terms, and I'm also going to tell you how they were able to build a model that's comparable to OpenAI's O1 at a fraction of the cost of O1. So in order for us to understand how DeepSeek was able to build their R1 reasoning model, first we have to understand a concept called reinforcement learning. Now, in super simple terms, reinforcement learning is just getting the model to learn through feedback, or basically just getting the model to learn or become better through the feedback that we give it. So in super simple terms, reinforcement learning is something like this. You'd give the model some sort of task, the model will do or give you an answer, and then you would give the model feedback on that answer that it gave you, and the model will then learn from the feedback you gave it. And then once it learns from the feedback you gave it, it will go back to completing the task. So it does something, you give it feedback as to whether it was good or bad or what was good or bad about it, and then it learns from that feedback that you gave it, and then it tries again. And if you continue this loop for multiple tasks and multiple examples, eventually the model will become better and better at doing certain things because of the feedback that we feed into it. Okay, so now that you guys understand the concept of reinforcement learning, let's take a look at how DeepSeek was able to use reinforcement learning to create their R1 reasoning model. So inside the research paper that DeepSeek released about the development of their new R1 model, they talked about GRPO, or Group Relative Policy Optimization, being the reinforcement learning algorithm that they used. Now, I'm not going to get into the technical explanation of this mathematical equation that basically just explains how GRPO works, but I will explain it to you guys in super simple terms. So as I said, GRPO being a method of reinforcement learning, it's basically just a method of trying to optimize how the model behaves based off the feedback that we gave it. Or in simple terms, it's just a way to improve the model based off the feedback that we provide to it. So when it comes to GRPO, there's two main parameters that you have to think about. First one is policy, and the second one is the reward. Now, in simple terms, policy is basically just how the model behaves, which is what we're trying to optimize. And the second parameter, reward, is basically just the feedback that we provide the model. So then the whole idea of GRPO is literally just to get the model to behave better with the feedback that we provide it. Or in other terms, getting the model to change its policy in order to maximize the reward that it earns. Now, to give you guys an example and show you an analogy that will allow you to think through this a little bit easier, let's take a look at this example. Now, as you guys may know, if you have a dog or any sort of pet, the way that you train them in order to do good things is by giving them rewards when they're doing good things. So for example, in this photo, as you can see, the pet owner is giving his or her dog a treat when the dog is sitting down, and it's basically trying to train the dog to sit down as a good act, right? And GRPO is technically just the same thing. You want to get the model to do something, and if the model is doing the right thing, you want to reward it for that, and then the model will try and optimize itself in order to do the right thing more and more often. And as it optimizes itself to do the right thing more and more often, it basically just becomes better and better. So the idea, as I said, is to get the policy to change in order to maximize the reward. And so what DeepSeek was trying to do was to get their non-reasoning model, or DeepSeek version 3 base, which is basically just a model that predicts the next word, similar to GPT-4o, which is, let's say, trained on the internet, to then become a reasoning model that's capable of reasoning or thinking. And in order to achieve this, what they did is, you guessed it, take the model through a process of reinforcement learning with GRPO, or basically getting the model to optimize itself with feedback. Now, the feedback that they gave the model was based on two criteria. The first one was accuracy, or how good the output of their responses actually was. So if you gave the model a prompt, then the model thought about it, and gave you an answer, how good was this final output? So that was the first component of the feedback they gave it. And how they actually were able to assess the accuracy of the answers, the outputs the model was giving, is by basically creating or using a data set that had predefined outputs from before. So for math questions, they had the answer to the math question. And for coding tasks, they had a bunch of test cases that they used on the code in order to see how well the code performed, or basically in simple terms, how correct the code actually was. So that's the first thing that they gave feedback to the model on, the accuracy of its outputs. Now, the second thing that they optimized the model on was the formatting that it used when it was thinking through the process and also providing the answer. They wanted the model to put its output in this sort of format. So put thinking in this sort of format and put the thoughts in between. So think, and then that's all the thoughts that it has, and then another think at the end. And also they wanted the model to put its answers in this sort of format. So just to show you guys an example, this is kind of what I mean. The model puts its thoughts. So when the model gave a response, it puts its thoughts between think, and let's say if this was the end of its thoughts, it would say think, and also its answers would go in a format of answer. That's the actual answer and answer. So by doing this, they wanted to format the model in a way that the model basically learns to think. And that's exactly what happened. The researchers at DeepSeek were able to get the model to over time learn that by giving longer and longer responses, or by thinking about the question for longer, it's able to increase its reward, both in terms of accuracy and formatting. So they were able to get the model to perform like a reasoning model with a simple prompt and an algorithm that gave it feedback based off the answers that it was giving. So then after this long reinforcement learning process, they were able to create the first version of their reasoning model, or the DeepSeek R1 0. Now, this first version of DeepSeek's reasoning model with just the reinforcement learning was already performing on par with some of the best models out there, like OpenAI's R1 on multiple benchmarks. But it still had two major problems. First one, poor readability, and the second one, language mixing. So in terms of poor readability, all it really means is that the model was producing good outputs, but the thoughts that it had were super messy. So it was very hard for a human to be able to come and interpret the thoughts that it had in order to achieve the output. And the second problem was language mixing, which is actually a pretty interesting problem. So as you can see in this example, the model was thinking through the problems in multiple languages. So it wasn't just thinking in English the whole time. It was thinking in English, then for a second maybe Chinese, and then maybe even other languages in there as well. And a cool thing that the researchers found out is that by taking away the language mixing problem, the model actually ended up performing a little bit worse. So although it kind of sounds crazy, it seems like AI models perform better when they think in multiple languages, not just one. Now, in order for the researchers to solve these problems, they had to use the R10 model as help to then retrain a new model called the R1. And I'm not going to get into the specifics of exactly how this happened, but if you guys want to find out more, I'll leave a link in the description to someone else's video that explains this really well. But what's important is that the DeepSeek researchers were able to get from the DeepSeek version 3 base all the way to DeepSeek R1 using the reinforcement learning tactic that I talked about before, their DeepSeek R1 version 0, and a bunch of iterations of fine-tuning with different datasets. But I'm not going to get into that today. Now, to be honest, this sort of reasoning capability, or even this level of sophistication in reasoning models, isn't something new. We've already achieved this before with OpenAI's R1 model, so realistically, R1 didn't really bring anything new to the table. But the truly groundbreaking innovation here is how cheap they were able to develop their R1 model. And in this section, I'm going to briefly explain how they were able to build it so cheap. So fundamentally, there's two things that made the R1 model so cheap to produce. The first one is the fact that they used a rule-based reinforcement learning tactic. So generally, how reinforcement learning works, as I said, is that you have to give the model feedback on its outputs in order to make the model better over time. Now, obviously, giving the model feedback is a very long and complicated process if it's going to be done by a human. And so DeepSeek's algorithmic reinforcement learning tactic was able to remove the human out of this process so that there was no need for someone to sit down and say, okay, this response is good, this response can be improved like this, and this response can be improved like this. Rather, it was just a mathematical formula that rewarded the model based on the outputs that it gave. So it basically made the process so much easier. And also, the DeepSeek researchers shifted their focus from supervised fine-tuning to reinforcement learning in order to create the reasoning capabilities in the model. Now, to kind of just explain to you guys very briefly what supervised fine-tuning is, supervised fine-tuning is basically getting the model to perform better by giving it examples of good input and output pairs. So in the case of reasoning, you would basically train the model on a bunch of question, thought, and answers. Question, thought, and answers. So what I mean here is that you would get a question, you would put the thought process in order to answer that question next to it, and then you would also put the answer to that question next to it, and you'd bundle it up, and then you would give it to the model as a good example that it should try and follow. So that if you give the model multiple of these examples of question, thought, answer, so then it starts acting like a reasoning model that when given a question, thinks out loud and then gives an answer. But as you can imagine, building this sort of data set in advance is super resource intensive. And so by the DeepSeek researchers shifting their focus from supervised fine-tuning being the primary method of improving their model's reasoning capabilities to it being algorithmic reinforcement learning, they were able to produce their model with much less resources. And as for the second reason why the R1 model was both cheaper to produce and cheaper to run as an API, we have to talk about a technique called the mixture of experts. So, as the name suggests, the mixture of experts technique gets the model, and as opposed to the model just being one big model that's an expert at everything, it divides the model into multiple smaller sub-models or multiple experts. And so using the MOE technique, when the model is given a prompt or a question, the model doesn't need to run all of the experts at once. It doesn't have to run everything. It would instead say, okay, for this prompt, we only need this expert and only this expert. So then it runs these two parts of the model and doesn't actually run the whole model. And so by using the MOE technique during production, they were able to get the model to only run smaller subsections of itself during reinforcement learning as opposed to having to run the whole thing, which decreased the amount of computation they actually needed to be able to train the model. And so it decreased the amount of money they had to pay in order to train the R1 model. And so at its core, that was the two main reasons why the DeepSeek model became so cheap. The first one was the shift from supervised fine-tuning to reinforcement learning, and the second one was using mixture of experts, where the model didn't need to run the whole thing every single time, but it rather run a smaller subsection of itself. Now, for completion's sake, I'm also going to explain to you exactly what DeepSeek did with their R1 model after it was actually developed to make it even cheaper and more accessible. So the DeepSeek research team used a process called distillation to make their models even more accessible. And all distillation really is just getting a smaller model to act like a bigger model so that you can have the accuracy of the much bigger model, but with the computational efficiency of the smaller model. So to kind of break it down for you guys in simple terms, you would have a big model that's considered a teacher and you'd have a small model that's considered a student. And what the teacher actually does is that the teacher teaches the student how it should be responding to questions and how it should be acting so that the student can replicate the teacher's behavior without actually having to be as sophisticated as the teacher. And so what this actually looks like in practice is that the teacher answers a whole bunch of questions and creates a data set, and then that data set is used to fine-tune the student so that the student knows how it's meant to act and react to questions similar to the ones in the data set. And what this allowed DeepSeek to do is create versions of their model which were only 1.5 billion, 7 billion, 8 billion, 14 billion, 32 billion, and 70 billion parameters, as compared to the actual DeepSeek R1 model, which was 671 billion parameters. So that if you had a use case where you really wanted the cost to be low, you could use one of these smaller distilled models as opposed to the big DeepSeek R1 model. Okay, so now that you guys understand the technical developments that DeepSeek's research gave to the whole AI industry, let's talk about the implications that R1 will have for the future of AI. First, let's talk about the positive implications, because honestly, the positive implications are much more important and bigger than the negative implications. The first one is that the model was released as an open source model, meaning that you can host the model on your own server. So basically what DeepSeek did is that once they trained their O1 model, they released it out to the public so that you can go basically download the R1 model, use some sort of computer, some sort of GPU, some sort of server to then run the model for yourself, completely independent of DeepSeek and China. Now, the fact that you can run the model independently on your own computer might not sound like such an important thing after all, but in business use cases, it really well and truly is. Because let's say if you're a hospital and you want to use AI to do something with your patient's data, it's super important for you to keep that data secure. So you being able to run the model on your own private server inside, let's say, your own hospital, then you're able to keep your data completely secure and away from everyone else in the environment within your own business. So for high stakes businesses that keep very, very important proprietary data, having an open source model that can compete with the best model out there is absolutely revolutionary. Now, by DeepSeek being able to prove that you don't need massive NVIDIA GPUs in order to be able to build models that can compete with the best models out there, they actually reduced the barriers to entry for a lot of other people. So they basically proved that you don't need to be backed by the hugest, private equity and venture capital firms out there in order to be able to build good models. All you need is a bunch of really smart people to sit down and figure out cool algorithms in order to make up for the lack of computation or the lack of capital. You know, as they say, constraint brings innovation, and that's really what happened here. Now, this reduced barriers of entry wasn't just by proving to people that, yes, you can do it too, and this is the method of how we did it. It was also by open sourcing their model. So by putting their model out there with the parameters publicly available to everyone, other people are able to build on their model and take it forward in order to achieve better and better and more capable models. Because if you think about it, OpenAI had O1, which is the best model out there at the moment, but it was closed source and no one knew how the hell they did it, and they couldn't actually use the model to improve on it for themselves. But now having R1 out there as an open source model, you can literally download the model's parameters or download the model and then improve it yourself in order to build your own version that might be 10 times better than O1 and R1 combined. So the third implication, which is probably the most important implication of all, is the implication that it's going to have on the application layer or the adoption of AI. And all I really mean here is that by having a model that's both open source, meaning you can host it on your own server without having to give your data away to anyone else, and super cheap, meaning that you can use the API multiple times a day for a use case that might be very resource intensive if you were to use O1, but not as resource intensive with R1, the number of use cases or the number of real world use cases for AI just increased tenfold. So if you're someone that's interested in startups and wants to build an AI startup, right now with the R1 model, it's the best time to get active. Now let's take a look at the negative implications of DeepSeek's R1, or should I say the negative implications for big US tech companies. Now, I'm sure you guys are aware, but only a couple of days after DeepSeek R1 was released, the big US tech companies took a massive hit to their stock, with companies like Amazon losing about $206 billion, Meta losing $251 billion, and Nvidia losing a record-breaking $560 billion in terms of stock valuation. Okay, but why did the stock market take such a massive hit? Now, the answer is actually quite simple. If you guys have been following the whole US-China AI race, you'd know that the US banned the exportation of NVIDIA GPUs to China so that they could basically stop Chinese researchers from being able to achieve AGI or ASI first, because obviously if you don't have super advanced computers to train the models, it's going to be harder for you to achieve a high level of sophistication for your models, and it's going to be harder for you to achieve AGI and ASI. But DeepSeek being able to build a model that's comparable in capabilities to the best model from the US with, as they say, not much processing power at all, really proves that it's not just computation that's important when it comes to building a really good AI model. And what this really equates to is that the US tech companies don't have as much of a competitive advantage compared to Chinese tech companies anymore, because processing power is no longer the number one determinant of who's going to have the better model. And obviously that's why Nvidia took the biggest hit, because Nvidia was in this massive bubble of, I'm the only one that has these chips and everyone needs my chips in order to build good AI models. But then DeepSeek came out and released R1, and with that, they basically popped the bottle and proved to everyone that no, you don't necessarily need these amazing Nvidia GPU chips to be able to achieve cutting edge technology. Now, considering the fact that R1 was released as an open source model, and if you combine that with the fact that they prove that you don't necessarily need a whole lot of money and a whole lot of computation in order to build good cutting edge technology, then this just goes to prove that the barriers to entry for building good, sophisticated, cutting edge foundational models just got reduced by a lot. And what this basically equates to is going to be much more competition in the space in the future. So I'm excited to see how people are going to innovate and build on the current capabilities. And the last one is actually quite obvious. As I said, OpenAI spent about 100 million to train their O1, whereas R1 only used about, what was it, like 6 million to train their model. As you can see, there's a massive difference between how O1 was trained and how R1 was trained. And this just goes to question whether these US-based tech companies are spending their money on what they should be spending their money on. Maybe instead of spending so much money on expensive NVIDIA GPUs, they should be spending their money on getting talent to sit down and think about how they can do more with less computation and how they can use algorithmic breakthroughs to push us forward towards achieving AGI and ASI. Now that's everything you needed to know about DeepSeek's R1 and how it's potentially going to affect the future of the AI industry. If you guys haven't checked DeepSeek R1 out yet, I would definitely recommend checking them out. You can literally use the DeepSeek R1 reasoning model for free on DeepSeek's website. Just search up deepseek.com and make a free account and start a new conversation. And as I said, since it's open source, what you can do is you can literally download the parameters and run it locally on your computer if you have access to enough processing power. And if you're super cautious and you don't want to give away your data to China, you can even use platforms like OpenRouter to run the model on an external server that doesn't actually sit within China. So that's all for this video. I hope you guys found this useful and interesting. Like always, don't forget to like and subscribe, and I'll see you guys in the next one.